Yo, YouTube, what's up? So whittling away on this 2022-2023 SHSAT Handbook. I'm on Form B. We're going to do some of the geometry questions right now. If I got this, there only seems to be 3 or 4, and there's 1 or 2 that overlap. We're going to start on this page here and just go through some of them. So this hopefully is a short video, might be half an hour long. Let's see how we go. Might be 15 minutes. Let's see as well. All right, so let me get this tablet set up. Okay, we're good. Get rid of that. Okay. In a scale drawing of a triangular park, the sides measure 5 inches, 7 inches, and 8 inches. So let's do a triangle. It's not necessarily a right triangle, even though what I'm drawing probably looks like that. So it's telling us we have 5, 7, and 8 inches. So everything's in inches, 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 inches. No unit conversion so far. The perimeter of the actual park is 25 miles. Okay, so the perimeter of the triangle is equal to 25 miles. Okay, what is the actual length of the shortest side of the park? So 5 is the shortest side that they're giving us here, and they want to know the actual length, not the scale model length. So what we need to do is actually find the perimeter of the scale. I'll call this S. So the perimeter of the scale triangle is equal to 5 plus 7 plus 8. So we get 12, 20. That's equal to 20 inches. Let me just double check that. I'm going to add it back. It's 8 plus 7 is 15 plus 5 is 20. So so this one kind of yin-yangs between 2 questions. This is really about rate as well. Okay, so what we're talking about is the scale is 20 inches is to the perimeter of the 25 miles, right? So this 20 inches here was the perimeter of the scale, and the 20 miles is the perimeter of the actual park. Okay, so we have our ratio there, and that's really all we need. So if we have the 20 miles is to 25, 20 inches is to 25 miles, then we're going to set it into how many inches. 5 inches, the shortest side, is to how many miles. Okay, and at that point we took that rate and we set it as a proportion, and all we have to do at that point is to solve that. So we can get 20x equals 25 times 5. All right, so 20x is going to be equal to 125, and then at that point we divide both sides by the 20. Okay, that cancels out, and I'm gonna divide this by 5, I guess. So 5 goes into 24 times, and 5 goes into the 125 25 times. And everybody should know that that's 6 1/4. Okay, that would be A. What you could have done too, if you wanted to, and this is kind of a way to double check your math, so to speak, as one of the sanity checks you should do. The 20 over 25, that's the same as 4/5. Okay, and at that point, if we did the cross product or whatever, we could have saw in that case, let me write over here, we would have gotten 4x equals 25, and then when you divide both sides by the 4, we still get the 6 1/4. Okay, it may have also leaped out at you that since basically what we have is 4 is to 5 as 5 is to x, it should leap out at you that this is 1 1/4 higher. That's 4 times 1 is 4, and another quarter is 1/4 of the 4 is 1, so that is that. So if we did that same thing here, if we took the denominator of the 5, right, we would end up getting 5 plus 1 1/4, and it would give us the 6 1/4 that way as well. Just different ways to try to meander about the same kind of question. So this involved geometry and perimeter and ratio and proportion and other things that we wanted to maybe do. And if you notice, I did the proportion different ways. You could have set up the proportion. Let me slip this down slightly just to be clear. So we did, let's use the simplifier for 4 is to 5 as 5 is to x. Okay, we could have, or let me make that easier because we had the 20 inches is to 25 miles. That was the raw rate, if you will. Okay, and we're trying to set it up. We know the scale had 5 inches to x. We could have also done, just related to two of them, that the perimeter of the whole thing to the shortest side is equal to the perimeter of the actual thing over, that's what we're looking for, right? If we do the cross product, we would still get the same answer because we're still going to end up getting 20x equals 5 times 125. Or in the case where we're using the 4/5, that would be 4 and that would be 5. So we still get the same answer depending on how we look at the problem. There's different lenses that we can come in and look at the problem and do that. All right, so the answer here would have been A. 71 is A. Okay, 72 gets kind of ugly fast. So we have this seemingly jam-packed illustration, which seems to be a circle, and there seems to be a right triangle there. I say seems because we're not told that anything about it except for the points and the x and the 5 and the 12 thing. So if this is a right angle, then this here would also be a right angle because RT, which appears to be the diagonal if this was a circle, that means PT is a line then. RT is a line, so PT is a line as well, or a line segment at least. So if there's 90 here, then some of these two have to be 180, so that's 90. So that means triangle P, and I call this right here, I already did a slant. Let me call that G. So triangle PGS is a right triangle with a hypotenuse of 12. All right. So there's not much more we can grok out of here except for going through the identities of what a circle and a triangle and stuff actually is. And then we be kind of rando guessing stuff. So it says P is the center of the circle above. So we confirmed a whole bunch of stuff just by that statement. So P is definitely the center. That is not angle P, that is point P, right? This P right here, that does not mean this angle in here is angle P. It means this thing here that I'm solidifying in is point P. And R, S, and T are also points on the circle. So R is here, S is here, and T is here. All right, so that seems obvious if that was a circle and P was the center of it. Okay, so what is the value of X? We're trying to find that length from here to right there. Okay, and what I found is working with students on this question so many times is students keep focusing on the triangle, and you also need to see other things leap out. For instance, the radius here, there's a whole bunch of radiuses. The first radius is RP. Okay, the second radius is PT. Okay, and the third radius is PS. Okay, so how is that important? Okay, let me change the color of the pen here. It's important because if PS here is 12, and these are all radiuses, then they're all equal to 12. Okay, so that means line segment PT is equal to 24. okay? And if this whole line segment here is 24, then isn't it true that this question mark is the 24 minus the 5, right? So x would be equal to, sorry, and I said PT here, I meant RT. So if RT was 24 minus the GT, right? The G I drew where the right angles were, the GT there. So we would basically get 24 minus the 5, and that would give us 19. All right. And if we scroll down to the answers here, that would have been H. All right. So the key to this was not basically getting absorbed into the geometry and worrying so much about that triangle. Is trying to go a little more abstract out and figure out what's kind of going on there based on those kind of things, and saying, oh, this radius is here, and the radius, right? That's part of that line right here. So those radiuses end up being important. This turned out to be a medium level question, I would say, because of that. It's not hard math, but the notion of, oh, this is not about the triangle, this is about the radiuses. You kind of need a slap in the face to wake up about that. So for that reason, it became hard. But otherwise, once you realize the radiuses, and some are just to 12, and the double the diameter, which is RT is the diameter is 24, just becomes a no-brainer at that point, okay? So be careful with these kind of things. It's easy to get bogged down into the minutia of questions and kind of miss the point. So attention to detail is important, and just pull out of your hat what you need to pull out. When you're focused on the triangle and you can't come up with the idea, try to approach the problem a different way. And sometimes you don't know that way. But if you do stuff like listing out, if you list out what you know, just start listing out what's given. And sometimes it clicks into your head, oh, this is about radiuses or radii, right? Radii. So you need to be careful with those kind of things. All right. Okay, 73 is pretty much a classic question. So 71 was pretty classic. 72 gets kind of weird, the one we just did. 73 is pretty much classic. And this also incorporates algebra with the geometry as well. All three of these kind of did. So if we know this is 90, then obviously these two are 90. All right, and that's probably exactly what they're asking us. They're going to ask us what is x most likely. So let's just go for it. And the right triangle above, so we confirmed that. And there's a triangle. What is the measure of the smallest angle? All right, so it's a little more twisty than that, but we know that 2x plus 9, right? That one is the upper angle there, plus 3x minus 14 is equal to 90, because the sum of the interior angles of a triangle is 180, and this is already that. So we can take 180 minus 90, and we know the sum of those two must be equal to 90. So this point is just solving for algebra. We don't need those parentheses, but I put them in just to be clear that this was the upper angle and this is the lower right angle. I'm just going to put upper left and lower right, but that kind of has no meaning. So at this point, all we have to do is combine the two terms. We have 2x and 3x, right? So that becomes 5x. And we have 9 plus minus 14, right? So that would be minus 5. So we get 5x minus 5 equals 90. I'm going to add 5 to both sides. So I get 5x equals 95. And at this point, we have to divide both sides by 5. That goes away. Divide this by 5. And x is equal to, is that 19? Let me see, 40, 45. Yeah, let me just make sure I copy right. I have mild dyslexia and I copy numbers wrong. So 2x plus 9 equals 3x minus 14. We get 5x minus 5 equals to 90. Add the 5, 5x equals 95. Divided by the 5, we get x equals 19. What I'm going to do now And by the way, it's good they didn't use 19 as any of the choices because we have not solved the problem. So what I'm going to go do is go back and double check as a sanity check. So when I leave question 73, I'm pretty strong that I got the right answer. I'm going to plug that back in to make sure that that's the case. So if we have 2 times 19 plus 9, right? 2 times 19 is 20, that's 38, plus 9. So if I did that right, this should become 47. And this is going to be 3 times 19 minus 14. All right, so if I did this right, this should be 57 minus 14, and that's equal to 43. And it is true that 47 plus the 43 will give me the 90. All right, so I believe I got the 2 angles right. And it's asking, finally, what is the measure of the smallest angle? Well, it's going to be 43 in that case. All right, so this one involved a lot of scribbling, and especially with my double checking and sanity checking, and just to make sure that was really what the case was. All right. So that one's there. And I think the next geometry question is 90. And by the way, I would rank the ones that last one as medium as well. Not terribly devastational, but just because of the computational aspects. Okay, 90 I think are going to spin off by itself. Enough students have problems with that I'm going to spin that off. And then there's, I believe, 110. And that will be the last question we're going to do in this little snippet bunch. Okay, yeah, 110 wasn't so bad. I pointed this out in the errata that I did for the handbook, though, because I believe there's an error in the question. So we always like to look at the illustration. It appears to be a right rectangular prism. But I think there's a fallacy to that. But let's just, right, because we did the thing, for example, with the one we just did with the circle. And then with the circle, and then all right, wait, I got interrupted for a second. We just did the one with the circle that I lost my train of thought. Where I look at an illustration first, and then I use the words to verify it. The problem is that there's nowhere a way to verify this. When you go look up the answer in the handbook, it defines this as the right rectangular prism, but I don't find that that's here. So it says, what shape will result from the horizontal slice of the figure above? So that's its own thing here, but they don't tell us what the figure above is. And even if we go by these right angles here, this right angle here, and this right angle here, it doesn't define basically what's happening with all these angles over here, including in the back, right? So there's this stuff back here like this that it doesn't really define for us, all right? So we need to figure that kind of thing out. So we can only assume that it's a right rectangular prism. So I'm just going to put RRP here. And the best we can go by is that now we have to kind of use the answer choices to figure out and confirm that without them actually saying it. The problem I have is that the answer says this is a right rectangular prism, and we're not informed that that's the case. So all we can do at this point is use logic to figure it out. Because here's an example where if this actually was 90 and this was 90, who's to say that this side here was not actually slightly off, and that this angle right here, we don't know that that's literally 90, right? So that's the problem. So we don't know that this is actually a right rectangular prism. And then if that was slanted, the back might be slanted as well, right? This could turn out to look more like a wedge and we take this part here and just throw it away if we cut it off like that. So in any event, minus that idiosyncrasy of this question, what they're saying is they took a horizontal slice. So this also assumes that the right rectangular prism is standing vertically, okay? So if you take a horizontal slice, we're going to take, imagine a knife, right? We're going to take something and just cut it through here so that it goes straight through, all right? So at that point, if this was a right rectangular prism, we're going to have basically a top piece if we cut it off that way, and then a bottom piece underneath it. And, you know, let me just erase that. I drew that slightly sloppy because it's interfere with the answer to the question. And if that was the center parts. So if you will, this part here I'm scribbling out right here, I'll call that A. This is A, and the part I didn't scribble out is B. So if I ran a horizontal slice through it, what would be the shape of the figure from the above? Okay, and basically we're really looking at the top or the bottom here. So if it was a right rectangular prism, this is basically a square stacked on top of itself infinitely. All right. So if the sides were 2 by 2, this is a 2 by 2 square, and that would have to be the answer. There is no choice with the triangle. Okay, the base was the so-called base down here is obviously a square, and again, they didn't define that all for us. They should have put right angle thingies, delineations down here, or use words to tell us that. But there's really no other choice. It clearly is not a triangle, even though it's not drawn to scale. Okay, so that pretty much rules out F and H. And then it says a rectangle that has a side of 2 and a side of 6. That would be a different slice, okay? That would be as if we slice it going down this way. And we had a left and a right part. But in this case, since it was a horizontal slice, we had a top and a bottom part, all right? And that's really what's going on here, okay? I'm going to spin that other question off into its own video by itself. All right, guys? Peace. Hit me up if you guys need help. Like and subscribe.